Good afternoon, everyone. Go ahead and get started on the second half of the presentations today. The first one of the afternoon is given by Drina Holman from SHARP, Statistical Centers for HIV/AIDS Research and Prevention, and Britt Pueller, who you heard from this morning from LabHeat. So this is one of the other big projects that we've been collaborating on. Kind of the big scale, similar to Argos in that way. Talk itself is a collaborative Dataspace program, an integrated approach to HIV vaccine data exploration. And there's a lot of really cool stuff going on in visualization and in other areas.
Great. Here.
Yeah.
All right, great. Hello, everybody. Good afternoon. I guess I'll just skip forward since that had such a nice introduction. So what we're going to do for our overview this afternoon is we'll start with our problem statement, tell you why we've developed this program. We'll go through the different components of the program. Britt's going to walk you through the application. And we'll talk about some of the considerations that went into developing the program. And then we'll wrap up with a few brief thoughts about the future of CDS. Okay, so what really started the idea of a collaborative data space is it started with the Global HIV Vaccine Enterprise. And for those of you who may not be familiar with the enterprise, it's an alliance of organizations that are dedicated to advancing and accelerating the discovery of an HIV vaccine. And in 2010, the Enterprise Council put out a strategic plan where they called for a dramatic shift in the culture and the practice of sharing research data. And what they were asserting in this plan is that there's actually a lot of untapped value in the data that's been collected in these studies for over 30 years. And that this data and the lessons that have been learned from this data over time tend to be siloed and not really accessible to the community at large. And so one of the things that they recommended is this creation of an infrastructure that would combine the data across these studies and these organizations and make it more easily accessible to the whole community. And so this idea really resonated with us because as a stats center, we actually are the keepers of a lot of the data that they're referring to. And so we are well aware of the siloing effect and how it can be very difficult to get a hold of this data. So just to give you a sense of the process that we currently have, let's say that I'm an investigator and I have a scientific question that I'm trying to answer. In order to find out if there's any data that I can even look at, there's quite a few steps, quite a few resources that I can go to find this information out. Let's say that I try to get the data. Well, there's very likely going to require an ancillary study request to get that data. A lot of approval processes in between. By the time I go to analyze that data, I'm going to need to combine it, to merge it across data sets and studies. And then in order to really answer my question, I may have additional information, metadata, methods, information about the assays that I need to get. And by the way, for a lot of investigators, once they go to analyze the data, they realize they don't have the data that they need, and they actually have to loop back into this process. So this can take months at a time, and it's a pretty frustrating process. We think that we can do better than this. We must do better than this. So enter the Collaborative Dataspace program. Our plan is to develop an improvement to the researchers' experience in data sharing. And the plan involves 4 critical components. The data component, which is a deeply annotated study catalog of metadata and study data. The services component, which involves outreach, analytics, and support. A governance component, which engages our networks and builds consistency across those networks. And then finally, the application, which is a web-based application that brings that data compendium together with the services and builds that governance structure around it. So when we went to define the scope around this project and this program, what we realized is it's equally as important to define what it should be, but also as equally important as to define what it should not be. So what we've designed the CDS to do is to help researchers discover basic facts and learn what data exists for those studies, to perform quick, low-cost tests of ideas, to compare data across the studies and assay types, and to communicate their findings. What we have not designed CDS to be is a source for statistical proof, a deep analysis environment, a source for raw lab data, or a repository of data sets. So let's take a look at each of the components of CDS. And what I'd like to start with is the application. So Britt's going to walk through that for you.
Thank you, Drina. Cool. So the first thing you see when you get to the collaborative data space is some sort of a welcome logon screen where you would log in just like any other IT system. Read my terms of use, and then click the sign in button. Much like Dr. Collins this morning, I was not brave enough to do a live demo, so or slide wherever this one goes. Sign in, and now here I am on the home page. To sort of help us walk through this, I'm going to do a semi-contrived scenario, but some have asked, or we'll assume some have asked, whether there's a relationship between body mass index and immune response for a given vaccine. Let's say that's our question. So we're going to explore the data space with that question in mind, and but first we'll start with a little tour. Up at the top here, we have the welcome section. This is totally contrived sample data, so there's nothing real here. It's a small data set with just 6 studies. The main content pane on the welcome screen contains some news, information about the field of the data space itself. On the left, saved groups and plots, things that you might want to come back to later. We'll at the end of this see how to save something. The filter pane, or the info pane, as we call it, over on the right shows the current selected set of subjects, the current data that was selected in the data space. So no filters are applied. This, again, this sample set has 477 patients across 7 races, 6 studies, etc. And then finally, navigation in the upper right. So let's walk through each of these, starting with the Learn About section. Learn About allows us to explore the catalog of study data. We may or may not actually have full data for all of these studies, but it lets us browse through and see all the current state of the field, the sort of work that's being done. I can scroll down, see a summary of all of them, drill in on one of them, and see, for example, the data types that were collected, what products were used, contact information, more about that study. I can scroll down. Down here, there's a global map showing with little pins the global sites involved in the study. Going back again, similar views for assays and study products. Again, this is quite sparse sample data. Moving on to find subjects. What you'll see here is something that's going to look quite a lot like the Argos interface. There's a common set of code under a lot of this. Find subjects is really around the definition, or enabling the user to define, in fact, a virtual cohort, to specify a set of attributes and examine that subpopulation of data space for a particular relationship. So let's say we're interested in, after browsing through the Learn About pages, we're interested in a couple of studies, a couple of SEMA. They may help us address our BMI versus immune response analysis. So we'll dig in to subject characteristics. In this case, we see distribution of races. what we really want to do with the study. So we'll select that. And then by shift-clicking on the 2 studies involved, I can set a filter over on the right. And now, in the current state, the filter hasn't been applied yet. The info pane on the right is showing us what data will be selected if we keep this filter. So this will knock us down to 442 of 447 subjects and just 206 studies that we talked about. If I click the Use Filter button, now all the other data from the other studies all goes away. From this point forward, we'll be looking just at only subjects who are in one of those 2 studies. Just go on the right. Now that we have at least an initial shot at our population, let's plot some data. Let's see if we can find a relationship between BMI and immune response. Start with the y-axis, and we happen to have an immune response variable, which is good. So I'll drop that in, and first thing we see, we've only selected one variable, so you see a simple box plot. There's enough data in this plot that what on the right there is in essence a one-dimensional heat map in a sense. It's not showing individual data points because of the density. When we go to the x-axis, we'll choose BMI enrollment. So right out of the gate, we have now 2 variables we're interested in on the x and y axis. In this case, again, we've seen really a heat map result because there's too much data here. So let's dig in a little further. How can we filter this data down? Look at the study products that are involved. In this case, we see, looks like we still have placebo subjects, which we clearly don't want if we're investigating an immune response to vaccination. So let's turn that off. All right, now we've started to drop some data out, and we're starting to get some. Maybe there's a relationship there where immune response is declining as we get up to higher BMI. It's not totally clear. From here, there's different kinds of investigation we can do. I can, for example, click and drag anywhere on the plot, select sections, and I can zoom in on those data points. I can use this just via the preview to see. Looks like I have 26 subjects who have very high BMI. Perhaps that's interesting in exploring. If I clear that filter, still not clear if we have a relationship here. So let's go back into the variable picker. And there's another potential X variable, which is the BMI category. Instead of using the raw value, let's go to a binned approach. And here, now we see, and apologies, these are not quite the right order. That was not ordered properly, but now we see the obese group. Perhaps, maybe that is slightly lower. Again, we don't know if it's statistically significant, but we've been able to explore the hypothesis. One of the things that we need to be careful about with this sort of quick and dirty data comparison is confounding variables, as I'm sure you all know. I won't go into it in depth, but we do have tools like being able to color data points and so on, so you can see if perhaps are all the obese subjects all from the United States, and some, we're seeing some other sort of variable in play. We color by country, and not an obvious country correlation here, so perhaps that's not a confound to worry about. So if we are confident enough that this warrants further exploration from here, switch over to the data grid. From here we can sort, we can filter, we can do all the stuff you can usually do with the latitude grid. In particular, we can export and hand this off to the statistician or statistical package and dig into it in some more depth. See if there's actually something here. So I'm going to save this group and come back to it later. Click the save button, provide a name. I get to choose, do I want a live or a snapshot? Live means that as more data flows into Dataspace, this population of subjects will be maintained. The filters are able to maintain the data on subject set may evolve over time. So that's a whirlwind tour. Go into questions now, or should we hold it in? Are there immediate questions about the application? Makes it easier.
Sure. Was this, is the data, when you're running this, do you load the data into this and that's what you look at, or is the data space, you like run it against pre-existing data?
The underlying data store here is the lab key study schema. And so one of the ways that we deal with security is by allowing you to load data by study into individual study folders. So you load it via study archive process. And then those folders can be secured individually, so different users will see different subsets of studies, different slices of the data, depending on their access.
So any data that I collect and create in a lab key study, I can then navigate with this.
Correct. And we would certainly like to, as a forward vision, it would be great if you could point the Dataspace application, just add an existing data warehouse. I think that's a great goal, something we'd love to do. For now, it needs to be a little more structured than that for us to make sense of it.
Okay, so Britt has shown you the nice, shiny lab key portion of the program, and what I want to do, was there another question? No. Okay. What I'd like to do now is talk about the other components, equally important but often unappreciated components of the program. It was interesting when Paul was talking earlier, he talked about how Hydra is both the application and the program, and I think that sounds familiar to us as well, because often when we talk about CDS to people, they think automatically about the application, and to us it's really just part of the story. You really see the CDS application as the tip of the iceberg, and we know that there's a lot of important work that's hidden below the surface. And that work is important to making sure that the data application is successful. And we think that it's really this tight integration of these four components that makes this such a powerful system. Well, why do we think these other components are so important? Well, let's take a look at each of them. The data component. Now, this might seem obvious. It's a data sharing platform after all. But there are a lot of different ways that you can go about this, right? So we've got three main elements that we think are very important to our data component. The data catalog, the integrated data, and the annotation. Data catalog is that comprehensive list of studies, all the products that have been tested, all the assays that have been run. And that's really important in facilitating the discovery of the data. It's telling everybody what's happened, what have we learned from this before, what's still there. And that's going to provide important historical context to the researchers as they're looking through that data. The integrated data. I said a minute ago that we decided that CDS was not going to be a place to serve as a repository for our data sets. Instead, what we've decided to do is focus on combined data sets. So we think that because the researchers aren't able to get the data in a combined format anywhere else, this is really what's of most use to our researchers, at least right now. Obviously, the higher the volume of data that you can get in there, the more powerful it's going to be. The annotation, this is really critical to the interpretation of the data. So annotation could be descriptions of the variables, it could be how a positivity call is calculated. It could be all sorts of information about the provenance of the data, what happened to that data between the lab and it getting into CDS. How did we manipulate it? All that's important to the interpretation of that data. And by the way, particularly for our area, probably true for other areas as well, I think having subject matter experts that know this data, know these assays, this is really, really important. You can't just point just anybody at this data and annotate it appropriately. Some of the considerations. Well, one of the first things we talked about was, all right, so we're going to build this thing. We're going to combine all this data in, and we're going to let these users have access to it. What if they do? What if they try to compare things that don't make biological sense? Should we let them do that? Should we restrict what they do? What we ultimately decided was that we weren't going to restrict what they did. We're going to let them do that, but what we're going to try to do is give them adequate information to make the appropriate comparisons. A little bit scary, but that's what we decided to do. Other considerations, the data model, harmonization, control terminology. Just to give you an example here, and this is, by the way, a huge part of the work. I'm sure a lot of you already know that from your systems. An example is that we quickly realized that a lot of our labs would use the same terminology for an antigen and mean two different things. Or conversely, they use two different names for the same antigen. And so we really had to put a lot of effort into identifying where we needed to apply that control terminology so that these data are comparable. And the whole raw versus processed data question. We know there are use cases for the raw data. We know that people want to get at that cell level, well level data for assays, but we decided that the biggest bang for the buck right now is for us to put process data in. The services component. We realized that we needed a services component when we started taking a hard look at some of our past efforts for data sharing platforms. We've got a few. And what we realized was, geez, we've done this a couple of times before. We put all this data in here. There's tons of data, but once you get it in there, what happens? Nobody uses it. They go there. Maybe they don't know it exists. Maybe they don't know what's up there. Maybe they don't know what to do with it once they get in. For whatever reason, we've identified 3 elements that we think are going to address this. The first one is outreach. And that's, the point of that is really promoting utilization and building the community around that. So that might be things like having sessions at the network conferences to work with potential users, showing them what they can do with this, show them what other people have done with it and what value they've gotten out of it. Really start having them share information, share experiences around that, and build that community around the CDS. Second one is the analysis services. And this really has 2 parts. The first part is around assisting the user to get all the way from that question to that answer. So providing statistical assistance wherever they are along that spectrum, along that timeline, and making sure that they can get all the way to the answer. If they're having a problem with their analysis or the interpretation, we've got statisticians that can help them with that. The second part of that is around strategic analyses. And this would be about making those statisticians available to the larger CDS community to do analyses that the community has deemed important, that they couldn't have done otherwise. And the third element is around support. And what we've settled on here, although we'd like to think that we are building an application that's so intuitive that no one needs support for it. What we've decided is sophisticated enough that we want to make sure that people are going to be able to be successful using it. So we've settled on a combination of self-service, tutorials that are inline, frequently asked questions, and facilitated support. Some of the considerations for the services component, maintaining accurate and current lists of users. Anybody who's maintained their user list for their lab key application or even a network directory knows that there's a lot of turnover and that maintaining these lists can be quite a challenge and a lot of work actually, but it's really important. It's so important that the people who have access to this data are authorized and current members of the networks. And then user metrics. We know that some of our sponsors are going to want to know that this is of value to the users. So there's metrics around that, satisfaction, ease of use. But beyond that, what other metrics are important to collect? Do we need to know what people are doing with the data? Hydra had a nice log of what people were looking at and who was getting at what. Maybe we need to be doing that. The governance component. So anytime you're dealing with clinical trial data and you've got multiple networks playing in the same sandbox, you're going to need some rules. And so that's what this component is about. The main elements are collaboration, data sharing, and harmonization. And for the collaboration, this is a major theme of the program. And we feel like by engaging our network partners in the governance structure, that we're going to see more buy-in from our network partners, and hopefully more ownership for it as well. The data sharing, this is about building some global data sharing and use agreements that can be applied for CDS on the whole. And we'll be negotiating those with our network partners. In the pilot phases of this project, we almost had a per study approvals. And it was a complicated process. And when you think about the hundreds of studies we want to try to get in here, we knew that wasn't a scalable process. So what we really want to do is build global sharing agreements so that we don't have to go each time and get approvals each time we're adding new studies. And the harmonization, this is really about building efficiency upstream. So let's sit down and work with our networks to build that harmonization as far upstream as we can, so by the time we're trying to integrate that data into CDS, a lot of it's already been harmonized and comparable. Other considerations for the governance, public access. We already know that at least one of our contributing networks has a requirement to include data that's publicly available. And we need to be able to show that publicly available data in the same plot as data that is more restricted. So how can we do that? That means we need flexible data sharing and collaboration levels, or you might think of it as permission levels, to allow that to happen. And I was interested to see what Adam was showing earlier, because I think some of that just might work. And then the last one is really sort of a cautionary tale, and I heard Paul talking about it as well. I'm really trying to identify those potential regulatory, legal, and IRB concerns as soon as you can, because those can be the hardest ones to resolve in terms of challenges. So when you put those four components all together, what we really get is an environment where your networks are contributing their data, their expertise into the CDS program. They're participating in the governance of that, and then in return, they're getting to utilize their data in a way that they haven't been able to do before in a combined fashion, and combine their data with other networks and organizations in a way that they haven't been able to do before. So just looking at that current process that I showed earlier and thinking about how that's going to look for the CDS. So for the main pain points that we talked about earlier, when you go to find out if there's data, CDS is going to show what data has been collected, whether it's available. It's easier to get the data because it's already been processed and there are agreements in place so that it's easily shared. When you go to analyze it, it's already joined, and there's annotation and interactive tools that are available. And then you go to find the answer to your question is deeper annotation and other resources that are available that are all in one place. And we think that's going to speed up the process and really increase the tempo of that question-answer cycle and really bring about additional new hypotheses and new insights into this data that haven't been there before. Hopefully that's going to bring us toward an HIV vaccine much sooner. So in terms of the potential future directions of CDS, although we did build this program with HIV vaccines in mind, we have done some thinking about what it would take to apply this program to other areas. So just sort of looking at a high level for the core components, things that would be readily applicable to other areas would be certainly the core platform of the application, some of the processes and structure around the outreach, the support and the engagement model for our networks. Things that would be a pretty good amount of overlap but probably would take some tweaking. We think the data model would fall into that category, probably some of the statistics and the analysis, maybe some of the reporting capability within the application. And then the things that are pretty HIV specific would be the subject matter expertise, some of the metadata configuration, and then obviously the agreements that are specific to our networks. Other than that, I think it's quite appropriate to think that this could be applied to other areas. So I just want to finish up with acknowledgments of our partners on this program for over the last couple of years. Artifact has been our product designers. They've done a fantastic job. In fact, I think Dave was here a couple of years ago and talked about the process that they went through. LabKey obviously has been doing a great job. And our partner IBM has provided some data integration consultation to us over the years. Any questions?
I want to ask you a question. We were talking about the services, and you mentioned user metrics. So what tells you that, okay, this is successful, it's catching traction? What would you use, or what do you keep an eye on to say, yeah, we're going in the right direction, oh, we have a problem? I mean, probably we all have ideas about, what we tell our funders and how we justify them. I'm interested to hear that too, but really, how do you keep an eye on it, and what do you use?
Well, first I clarify we don't use anything yet.
Yeah, no, that's fine.
But what we have planned.
Yeah.
I think just that. We've talked a lot about satisfaction surveys, and we don't feel like time logged in or those sorts of metrics are particularly useful. But we have also talked about ways that we could identify output from use of CDS. So things like how many publications. Is there a way that we can get the users to cite CDS as a way of indicating that they use CDS for that publication, and trying to track those sorts of things? We still have a lot, and if you've got ideas about it, we would love to hear it. But those are sort of our initial thoughts. I don't know if you have any other things to add to that.
I think that's exactly right. The temptation of anything web-based is let's crank up Google Analytics, let's see how many hits we get this month. And we think that's a rather poor proxy for measuring the scientific value of the site.
Yeah.
I do too, but I don't have any more ideas about
Right.
Well, it's hard.
about
We've struggled with that as well.
Yeah, but tying into publication is something that is intriguing, albeit it's going to take a while
That's
to measure that value.
Yeah.
You need patient funders,
Yeah.
if those exist.
I guess the other thing that you need to use within the data discovery index, so you have an identifier of the database that's included in your information. It's not relying on there being a publication about your data. That's the other problem. A lot of things. There's no endpoint publication to point to the endpoint.
Other questions?
Second question on metrics. So have your funders ever explicitly asked you for Google Analytics style metrics, usage directly, or do you get away with less specific guidance?
Our funders have been very specific about what kind of metrics. I think they're looking to us to provide those.
You mentioned that HIV was sort of the primary initial. You mentioned HIV as the area you're working in information networks. Can you say exactly what are the networks you hope to bring together and what's the same or different between?
For those who know the networks, they may be curious. Yeah, so, and it's different from the pilot you probably remember. So our current targeted contributing networks are the CAVD, which is the Collaboration for AIDS Vaccine Discovery, the HIV Vaccine Trials Network, and the predecessor network to HV10, which is the AIDS Vaccine Evaluation Group. We have all the data from that predecessor network as well. So those are our three target networks for now. We have a short list of networks we want to talk to next after we've accomplished this for those three networks. Early stages, we had also CHAVI and MHRP, the U.S. military research, the TIE trial work. So those were the other ones that were part of the pilot, and one of the things we did this last year was to try to refocus on three networks that we thought were a little bit more consistent and manageable, and go after that data.
So even though those are fairly close together in our research goals, there's still a lot of issues about alignment, language, and vocabulary and all that.
Indeed. Even within a network.
Yeah, I was going to follow up on that actually is, so you mentioned organization and this is key, and who's going to do that? Because that's going to take you doing the work, right? So what is the plan for organization before you actually go to the data?
For the integration part?
Yeah.
Well, in our data architecture.
Should we put Julie on the spot?
We could put Julie in the spot. It involves a team of people. That's people who are both data modelers and data over, ETL programmers to really take the source data and transform it into the model that we need in order to put it in CDS. And and the subject matter experts to provide the annotation. And there's a fair amount of work, metadata around the studies that needs to be extracted from documents and put in the system as well. So it's a ton of work, the database.
And we haven't committed to any particular, to my knowledge, I've committed to a particular tool, but one of the things that IBM has done in our discussion with them is they've shown us, for example, Infosphere, which has some very sophisticated data alignment capabilities, mostly designed for the business space, not so much for the scientific space. So, I think it's an open question of what's the best way to approach it. But there are tools out there.
Yeah, just what kind of tools they use, like, love your algorithm.
Yeah, suggestions, well.
Right.
Army of undergrads.
Other questions? Okay, thanks.
Thanks.
Thank you, Brent. Thank you, Drina. It's a great project to kind of see across the years and the user conferences, the progression from the design phase that Drina mentioned a couple of years ago to an actual system that you can log into, even if that wasn't part of the demo itself today.